podcast, we're going to look at structural formulas. So we've kind of talked about Lews Dot structures already, and really we're going to turn these Lews Dot structures into something that's a little easier to look at. So essentially the way these work is we're going to change pairs of dots into dashes. So when I rewrite this, I'm going to have C dash H dash H dash H dash H. Alright, and that's what methane, or CH4, is going to look like. Notice again just that two pairs of dots represent a bond, so they become a dash. For down here, silicon dioxide, we're going to have O, and then dash dash Si dash dash O. And the next thing you're going to notice is we are not going to put lone pairs of electrons around our outer elements, only our center element. So because Si has no lone pairs of elements above or below it, we don't put that. The other thing that we might notice is if we go back when we did this Lews dot structure, and I erase this red, and those two red dots, and put a dot back here. Let's say, I'm just going to put my red back, let's say I crossed out this lone pair on the bottom, and put another pair of dots here. Alright? I could just as easily write O with three dashes, Si, single dash, O. Alright, so what these lines represent are bonds. So I'm going to circle this right here. This is a double bond, and this down here would be a triple bond. So one dash, single bond, two dashes, double bond, three dashes, triple bond. And this is known as bond order. And the order can be either first order, second order, or third order. And it represents a single bond, a double bond, or a triple bond. And what I want you to know is, if it's first, second, or third order bonds are the shortest. So if we have a triple bond, our elements are really, really close together, much closer than a single bond would make them. Single bonds are longer, and then double are just going to fall somewhere between this continuum of a single bond and a triple bond. Alright, our last one is sulfur dioxide, and when we draw this one, we're going to see that we have O, single bond S, double bond O, but we are going to put lone pairs around our central atom. So because we have a lone pair on S, it's going to stay there. And you're going to see why this is important when we start looking at geometries. So anyways, that is going from Lews Dot into structural formulas. And then also a little bit about bond order. Something can be first, second, or third order. It's impossible to have a quadruple bond. But the bond order is simply equal to how many dashes you have on a given side, left side, right side, top side, bottom side. And bond order of 3 or triple bond is the shortest bond. And a bond order of 1 or a single bond is the longest bond. That's it.